Hello, my name is Karah, and my project focused on amyotrophic lateral sclerosis, abbreviated ALS, also known as Lou Gehrig's disease. ALS is a devastating adult-onset neurodegenerative disease. It is characterized by the death of motor neurons in our body, which control everything from blinking our eyes to breathing. Disease progression with such a loss in motor function is rapid, with most patients dying nearly 5 years after being diagnosed. Unfortunately, there is no known cure for ALS, and scientists are still unsure of exactly what causes it. However, in 97% of cases, they've identified a similarity. This similarity has to do with the protein in our body called TDP-43. In ALS patients, TDP-43 does not act properly. It goes out into the cytoplasm of their cells and accumulates. This accumulation of TDP-43 is related to the loss of locomotive function that people with ALS experience. Much of the information that scientists know about ALS and TDP-43 comes from studying Drosophila, or the common fruit fly. My science fair project investigated whether overexpressing UG-rich RNA, or ribonucleic acid, was sufficient to restore locomotive function in Drosophila with ALS. I looked at 2 different types of UG-rich RNA. The way I collected my data was through a method called larval turning. It can be a little difficult to explain, so it will work better if I just show you what it looks like. For the purposes of this demonstration, we're going to pretend that this ladybug eraser is a fly larva. What I would do is I would get the fly larva on a grape juice plate, and I would take a paintbrush, and using the paintbrush, I would turn the larva over, and then I would start a stopwatch. By its own means, the larva would turn back upright, and when it was back upright, I would stop the stopwatch and record the time. I turned healthy flies, I turned fly larvae with ALS, and finally, I turned fly larvae that had ALS in addition to UG-rich RNA. My results are shown here on this graph. As you can see, the healthy flies, the non-diseased flies, had an average turning time of a little over 10 seconds. The flies with only ALS had an average turning time of nearly a minute. As you can see, there is a huge difference between these 2 values, and it's clear that there was a loss in motor function. But when I turned the flies that had ALS in addition to the UG-rich RNA, we can see that the average turning time is closer to 20 seconds for the UG-rich RNA1 and about the same for the UG-rich RNA2. Since the turning time for the ones with ALS was nearly a minute and these were 20 seconds, there is clearly a statistically significant difference between these 2 values. Therefore, I concluded that overexpressing UG-rich RNA in flies with ALS did restore locomotive function. My project is extremely important, as before scientists can develop cures to any type of disease, they have to understand the disease on a cellular and then molecular level. My project is one step further in understanding ALS on the cellular level, which can hopefully and eventually lead to a cure for people stricken with this disease. Thank you.